Alright, in this video, Logan is going to implement the wall class. Now that doesn't mean that we're going to have a wall being embedded behind our bike as we're cruising around the level. Instead, what that means is we have the infrastructure in place for walls. Basically, we have the grid created in memory. And then what Logan's going to do is jump back over into the game class and just create a very simple demo wall to show you hard coding in some wall segments.
Right, to show piecing in a few different blocks of wall segments.
Exactly.
All right, so let's turn our attention to the wall class. And before we work on the class itself, let's set up a wall segment struct. This is going to be the struct that holds all the information for each individual wall block. As you had drawn on the whiteboard, this is going to be the things like filled, texture index, and player index.
That's right.
So, our wall segment struct. This is going to be, as such, named wall segment. Wall segment contains the three fields. First one is a public boolean called filled. The second is a public byte called texture index. And the third is a public player index called player index. And that's it. Again, wall segment is just a grouping of information that we might want to bring up for each individual wall segment. Now we can look at the wall class. All right, we're going to add one field to the wall class, and that is the segments array.
Our two-dimensional array.
This is going to be a public static array of wall segment. It's going to be a two-dimensional array, so I'll define it with the comma in the brackets. And the name of this array is going to be called segments. Alright, now let's skeleton in the methods that are going to be contained within the wall class, starting with the static constructor. So we have static wall. After that, we have a public static reset method. We have a method that is used to take an individual point within this grid and get the overall rectangle that represents the space occupied by that grid point, or the full grid block. So this is going to be a public static method returning a rectangle, and it is going to be called getPointBounds. And it's going to take in two parameters, two integers for x and y. And then one final method is going to be a public draw method. Now, you might want to be tempted to try to write this down as an override, but we have to remember that wall does not inherit from actor, and therefore, if we try to override anything, there's nothing there. But again, we're not inheriting from anything. There is no draw method yet. So we make our own new public void draw. Actually, this probably has to be public static, and I get the feeling I'm missing void from some other methods, namely reset. I'll get to that in a second, though. Let's finish off draw. Public static void draw, and we will take in a sprite batch. And before I forget, let's go back to reset for a second, because reset does not have a return type.
Right.
All right, now let's turn around and implement these methods, beginning with the static constructor. All the static constructor is going to do is to make a call to reset. Reset is going to initialize the wall segments array. So it is going to take segments and set that to a new wall segment array, and now we need to plug in a size for this array. The size is going to be given by the overall grid width and grid height. So we need to look at game 1, we need to look at the grid width and use that for setting the first dimension of the array, and look at grid height for the second dimension.
Yeah, as a matter of fact, we had mentioned that a couple of videos back that grid width and grid height were not pixel numbers. Basically, we're talking about the number of elements in the array, and here's where you're actually plugging them in.
And as you had pointed out, they could be. If you set a grid block size of 1, then they would correlate to pixels. But we have a grid block size of 8, which means that these represent 8 pixel chunks instead of individual pixels. But that takes care of reset, and now we can turn our attention to getPointBounds. GetPointBounds needs to return a new rectangle. So return new rectangle, and then we'll construct a rectangle. We're going to use x and y but we need to return this rectangle spaced out for the grid, not for pixels. So x needs to be multiplied by the grid width. So game1.gridWidth. Y also needs to be multiplied by the, or is that grid width? Did I put grid width up there? I meant to put grid block size. Because times the grid width means we're going to make a rectangle the size of the entire screen.
Yeah, it's grid block size.
So, yes. Better to catch that now than later.
Oh, yeah, for sure.
So x and y multiplied by grid block size. Then we need to set the width and the height, which is even more simplistic. We simply use grid block size.
Right.
And that will end off our rectangle. And that is all we need to do inside of getPointBounds.
Okay, so now down to draw.
Let's notice one other thing. I named bounds with a T.
Ah.
That is also incorrect.
Okay, so let's go ahead and jump down to draw, where we'll set up our nested loop scenario, where we're going to basically walk through all of the elements of this two-dimensional array.
All right, walk through them one by one, gathering x and y coordinates. So the outer loop, we'll make a for loop, expand the template, we'll name the index variable x, and then we'll loop for all of the grid blocks along grid width. So for game1.gridWidth. Then we'll make a nested loop, again expanding the for template, this time naming the index variable y, and looping across the grid height. This will go through all possible x and y values for our grid array. Inside of this grid array, we need to check each individual segment and see if it is filled, because if it's not filled, we don't want to bother trying to draw it.
Right.
So we'll look at the current grid segment, which is segments sub x by y, and we'll look at its filled field. If it is filled, then we will draw. If not, we'll skip over it. Now, if it's filled, the next thing to figure out is what texture should be drawn for this segment. And all of this could be put in line in the draw call, but I'm going to break it out into individual variables. It will just make the code a little bit easier to read. So I'm going to make a texture2D variable called wall texture. Wall texture is going to look at game1's wall textures array, and it needs to find it needs to plug texture index into this array now. Now, of course, texture index is held within the current segment. That means we need to look at segments x by y dot texture index. Then we need to know what color to use for this wall. So I'm going to make a color variable called wall color, and we need to look at game1's player colors array. Player colors takes in an integer to address the array, but we have a player index. This is the same scenario we had back in Bike when we needed to pick a tail color. So we'll do the exact same thing. We need to cast to int our current player index. That is segments sub x by y dot player index. And that should address the proper color. Now we have a texture and a color, so we're ready to draw the grid block itself. So let's use the sprite batch, make a call to draw, and for once we get to use the first overload to the draw method. We'll plug in our wall texture. The destination rectangle can be gathered using the getPointBounds method. So we could say getPointBounds x and y is the current x and y index variables inside of the loop. Color has been found and stored in wall color, and that finishes off the draw call.
Very cool.
Let me build briefly, make sure I've introduced no errors, and the build has succeeded. So now we can turn our attention back to the game class. The first thing we need to do in the game class is go down to the drawing section and make sure that walls are drawn, because up until now wall has not had a draw method, so we had nothing we could draw. Now we can look at wall and we can tell it to draw. And of course it's going to need to look at the sprite batch in order to perform any kind of drawing. Now we can start messing around with the wall. Of course we could build and run and we simply see no walls because we have created none.
Right.
All of the segments right now, if we look at the wall class, have not been set. So each of these are going to have their default value. Filled is going to default to false, texture index to 0, and player index to 1. But filled being false already discounts it from drawing anything.
Right.
So inside of the game class, in create scene, let's make a demo wall. Let's string a few blocks together using filled segments. Let's first look at wall.segments. Let's look at grid segment 20 by 20.
Okay.
And let's set its filled to true. And just leave it at that. If we run now, we have a green wall segment at 20 by 20.
And notice it is a horizontal line, which is what we should be seeing because the index of 0 was a horizontal line.
And we can check that down here. Looking at the wall textures, sub-0 is in fact wall H,
Perfect.
so our horizontal wall segment. So let's see, what if we wanted to change that to a vertical wall segment? Well, I could copy this line so we have everything necessary to address 20 or grid block 20 by 20. But let's look at its texture index. If we set the texture index equal to 1, we now have a vertical wall segment.
Perfect.
Or we could set it to 2 and we should have the top left corner. And we do. I'm going to leave it vertical though, because the next thing I want to look at is the color is red.
Mm-hmm.
So that must mean that the player index is defaulting to 2, which is actually interesting. Let me, if you don't mind, let me look back in here at player index. And red is set to, wait a second, what is that resolving to? If you don't mind, I'm going to set a breakpoint on the draw, because I am curious as to why player index. Let's look at the line where we're gathering the color. Set a breakpoint on it. Player index is set to 1. Player colors 1 should cast to 0, but instead it's casting literally to 1. Let me see what would happen if we set it. Let me actually set it here. Dot player index equals player index dot 1. Changes it to, wait, it was green, wasn't it? I think I just got backwards in my thinking, because that's going to leave it still green. For some reason I was thinking it was red. Don't ask me why.
You were really thinking oh wow.
I think I was actually thinking to a different day when I had written a different version of the code.
I got you.
So I just now debugged something that didn't exist. It's like 2 days just like completely overlapped.
Okay, just for the record, that's kind of scary, because I was just sitting here thinking,
what on earth is wrong?
Look, he's saying it's red, but okay.
I'm staring at this very screen saying, why is that point red? I don't understand.
Well, that's just awesome. We caught this on video.
So now we get to document me going insane.
Yay!
So it was 1. I have changed nothing.
So
if I wanted to change it, if I wanted to make it actually
which
red,
is what I thought you were going to do to begin with.
We could for player 2. So while my brain is not working, the code is in fact working. So at the moment, the code has a higher integrity level than my own brain. So,
so let's go ahead and continue with 20. That's for X, and let's go like 21 and 22 for Y. Let's start running a vertical wall.
I see. So you want to start duplicating these blocks down.
Yeah.
Let's grab the entire 3 lines, paste them in, and drop one below. That is, let's increase Y. And leaving all the same textures has one more block filled.
All right, now let's go down one more and put a turn to the right.
So a turn to the right. If we're going down, then to the right, that would be the bottom left corner.
So that'd be 5.
And that would indeed be 5. So and again, move this down to 22. Texture index of 5.
Very nice.
And
now let's leave Y at 22, and let's increment X to 21.
So X to 21, Y to 22, and then the texture index to a horizontal line, or 0. And we have now simulated rounding a corner and continuing on a straight line.
So obviously the wall class is working the way that it should be, and we're able to create a wall here. So that's pretty much everything that we set out to accomplish in this video. So in the next video, we can tie everything together so that the bike is actually emitting the wall behind it, and we can go ahead and get collisions tied in and get the smooth movement in place for the bike, and that'll wrap everything up. So with that, that is going to conclude this video. Thanks a lot.